Welcome to our special webinar, CustomWebResolver. I'm Pascal Bieler, I'm your trainer for this afternoon, and I'm a senior developer here at Quality First Software. With Custom Web Resolvers, we want to learn how to improve the understanding of QF test of your application, how you can improve stability and the recognition of the components in your application, and how we can get better test results and therefore a better quality of your products. So let's have a look on how a web application is developed and what QF test sees of a web application. In the beginning of a web application, let's say of the life cycle of a web application, there is a sketch, for example, coming from the design department, and they say, well, we need a web application which looks like that. For example, here we have kind of file browser. So developers take this and develop this. So developers take this and they develop this. So they write their code. For example, here, this is taken from Vaadin. To implement this file browser, they take a TreeTable component and they make something with a TreeTable. They add properties to it. They remove properties. They add data provider. So in fact, to display such a thing, they interact with a TreeTable component. And when you watch your application then in the web browser, you get the TreeTable component. So everything's fine. The user interacts like he or she interacts with the Windows Explorer. The interaction here is with this TreeTable, the same like File System Explorer, where you can click on nodes, you can expand nodes, you can collapse them, select them. So everything is fine, except when you select show me the HTML code, so show me what the browser really gets from the web application. So what the browser really displays, there is no TreeTable there. There is a div and another div and another div and a span and a lot of attributes, a lot of CSS classes, probably some JavaScript to make the collapse and expand animation. So what the browser sees of the TreeTable is agglomeration of a lot of div tags, which, well, for the user doesn't matter because the user sees the TreeTable, but which matters for any application interacting with the HTML code or with the DOM node which the browser has of the web page, for example, for QF test. So if you're going to record some clicks on this TreeTable component, you get a recording which is like that. I've done the recording on my system, so please excuse if some labels are in German here, but well, the idea is the same. So in the component tree, you see here that a lot of divs have been recorded here, and there's some table and some TRs and some TDs and some divs again and some spans, but there is no tree anywhere there. So the clicks which have been recorded by QF test are clicks on span components and div components, and not like you would expect, for example, from tests you've seen with Swing or FX or SWT, where you have like the table and then you say, okay, click on the table and select the item, and then with slashes you define the item, first item, second level, third level, click on this level, and then QF test will auto expand everything and click everywhere magically and can interact with the TreeTable. Well, this is not possible here because QF test doesn't know of any TreeTable, just of divs. It would be so much nicer if the recording would look like that. So if the recording would just have what the user sees. So the body and then the TreeTable, the rows in the TreeTable, and the table cells, and then those of expanders where it can click on and select everything. So that would be great. So how to do that? This is not a mock-up. This is a real QF test screenshot. So yes, it is possible. And well, it's pretty easy. For those who have been with me in spring webinar, we had a webinar about resolvers. I told a lot about how to modify the view of QF test on your system under test with resolvers. And well, the same is true here. With resolvers, you can get exactly that. So with resolvers, you can teach QF test how to see the application like your user sees the application. Despite having different web frameworks which show, for example, TreeTable components or other components, in a completely different way. So we can teach QFTest to do like that. So let's see what we want to do today. We take a short look on the resolvers. That would be a recap for those who've been with me in spring. Hopefully it will be a recap only. For the others, that's something interesting to know. And if you haven't seen, well, check out resolvers for QFTest. They're really, really powerful. So even if you don't do only web testing, but you do Swing and FX testing, or SWT or Windows testing, which is available by now as well. So if you do any testing, you get the full power of stability with common component recognition with resolvers. So we will see that. We will see which resolvers you will use typically for your web applications, and then why you don't need them at all. But well, that's the custom web resolver. That's what we're really about today here. So this will be a third part of this presentation. Then I will show you how to configure the custom web resolver in a way that it really matches your application and the framework you're using with your application. I'm showing complex components. And then if we have enough time, which we hopefully have, I will do some live demo and demonstrate how you really take your application and dissect it and find out how to get the relevant parts of the application to teach QFTests what QFTest needs to know about your rendering. So, well, let's go into it and let's start with the QFTest resolvers. So as I've said, resolvers are kind of some code snippets which are executed within the context of your application. So for the expert under us, it's an SUT script. And these scripts will register kind of lenses for QFTest to look onto your application. So they changed the view QFTest has on your application. And with that, you can override the attributes QFTest records and uses for recognition during your test execution, like for example the name of the component or the feature, the extra features, the ID, whatever you need there, like which kind of component that is, like the class. This all is configurable with resolvers. So when QFTest, for example, records some component, let's say we have a pretty old Swing application and we click somewhere, then QFTest asks the Java, well, what's that kind of applet control? And Java says, well, that's a J label. And then you have your custom resolver, which says, okay, that's not only a J label, but it's our custom J label, and it has these features and so on. And you can do that with QFTest, and you can implement resolvers in JSON, Groovy, and JavaScript, or directly in Java. We can use that as well for web application. Normally, web components only have the type DOM node, which is not pretty interesting because, well, every DOM node has a type DOM node. And then QFTest inspects the tag name like div or span, like we've seen, for getting kind of a class for that. So it makes up classes out of tag names. But, well, that's not the most powerful we can get here. So, for example, if we implement an interesting parent resolver, we can teach QFTest which levels of your website are important for recognition. So which of them carry like semantic meaning, and which levels, which components are only there for, let's say, structuring the information for visualization. So for like having a container for a CSS class which removes some border or which sets some margins. And we don't need them for recognition of the components. We don't need them for replay. So it would be better if they wouldn't be there at all in our rendering. You remember the image of the thousands of divs inside div, inside div, inside div, and we don't really need them. So we have the interesting parent resolver, which says, well, this is really an interesting element, and this one is not an interesting element. And then normally, QFTest takes the ID attribute of a DOM node to make up the name of it for the components which are recorded then. But, well, if our framework doesn't like to set ID attributes, but sets something like super duper framework ID attributes. Using an ID resolver, we can say, well, let's take this super duper ID attribute instead of ID to use that as a name for components. And voila, QFTest uses this. With the feature resolver and extra feature resolver, you can collect more information like inspecting the DOM nodes around your click DOM node to get some labels or to get other information which you want to use for recognition, which is pretty powerful. And then we have the generic class name resolver, which is used to assign a kind of typical component to a DOM node. So to teach QFTest that this div, in fact, is not a div, but a table or a button or any other components like from this list, which is typically used for QF-test. So QF-test has this internal list of generic classes. You can make up more if you need, which sometimes has pretty important significance. We will see that later. But these are the integrated classes, and you find them all in the manual. We have a set of input and output classes, where QF-test knows that there, for example, you can check data and you can enter data, enter information. Then we have interaction classes, where QF-test knows, well, a button is clickable or a radio button is clickable. On some sizer, you can move something and so on. Then we have containers, which contain other elements where we know, okay, we can go inside and QF-test checks the content. And then, for example, in a calendar checks that there is some specific date selected and so on. We have complex components. We'll see about them later. So in fact, there's components which contain of subcomponents which are important for recognition. And then we have the subcomponents which contain the data to check or to manipulate. So these are like the parts of complex components. And I've said, well, there you find them all in the manual in chapter 55. You will see there that for every property, for every generic class, we listed the properties. We have listed how QF-test uses it, how QF-test interprets it, and well, it's interesting reading. You can do that for yourself. When do you decide which generic class to assign your DOM nodes to? It can be pretty cumbersome to implement all those algorithms yourself. Like every time you just want to take a role attribute and assign this directly to a generic class, saying all elements will have the role attribute list should be lists, and all elements will have the role attributes set to list item should be treated as list item, and so on. Since these are all the time the same resolvers, we pre-implemented those typical algorithms and named this CustomWebResolver. And for a lot of frameworks, we have pre-programmed resolvers to map the elements of those frameworks to QF-test generic classes. And we teach QF-test in a different way how to use, for example, how to get tooltip information and so on for those different frameworks. So if your application uses one of those popular frameworks, you're probably already done. So you just have to run this procedure call, install CustomWebResolver from the standard library, which is included in every QF-test test suite. And if you use the Quick Start Manager to create a start sequence for your application, you have probably already seen this dialog where it asks, well, which of those frameworks your application uses, and then it integrates this step, install the CustomWebResolver. And for example, here we install the CustomWebResolver for Vaadin, but well, you can also write auto detect here, which is also the default if you don't select anything. And then QF-test will inspect the website and uses some heuristic to find out which kind of framework your developer have been using to develop your web application. And probably you're already done here. You can quit now and say, okay, that's fine, everything works. But probably also your developers have been creative or they've used another framework and you need some custom modification. Since it's named CustomWebResolver, well, it's customizable. So let's see how to customize the CustomWebResolver. To customize the CustomWebResolver, simply write custom in the name field. So where we have auto detect or we have here Vaadin written, we can also write custom. And then we use the parameters of the procedure call to tell the algorithms which are kind of the input and output values of the algorithm, so of the pre-programmed resolvers to execute to get exactly the result we need. So there are a lot of parameters and a lot of parameters. The CustomWebResolver has been improved since a couple of years, and more parameters have been added for special cases. We will look at some of them today, which are the most important. The others you can see documented in the documentation of the standard library, which is directly available from the QF-test help menu. Let's get started with some of those most important cases. And I already said, well, one important case is that probably you want to map a CSS class of an element directly to a generic class in QF-test. And exactly this is possible using the generic classes parameter. For example, here we have an except from an HTML page, and there we have an element, and this element, well, is a div like everything. So a div is like the most powerful HTML tag I've seen, or the most, well, misused probably as well. And then we have some CSS class here assigned to make it look like a button, which is named CSS button, which is pretty nice for us. And we want to teach QFTest that this div element with a CSS class named CSS button is in fact a button. So what do? We use the generic classes parameter of the install CustomWebResolver call and write CSS button equals button. So a CSS button is a button. You see the generic classes there, then comes the name of the CSS class, then the equal symbol, and then comes the name of the generic class from the big table I've shown you. Because this is not really readable here in the screenshot, I just extracted this to a bigger font, but the same. Please be careful here, no space before or behind the equal sign, because otherwise QFTest would assign a class which is space button, which probably makes sense to you, or looks for another class name. Probably with generic classes, since the space is a separator, it doesn't make sense. But if you see later and use attribute values, you can use a space there. So space is important. You can put inside the parameter several mappings. So you can add another mapping with a comma and then say, well, every element with the CSS class CSS checkbox should be a checkbox. And for better readability, it is possible to add line breaks after the comma. So then you can use the edit button in QFTest and have a multi-line edit, and this multi-line edit pretty comfortable to put all those assignments there. And you probably have a long list about CSS classes in your application should be mapped to which generic classes. Another way to define a mapping for generic classes is to use the name of the HTML tag. So for example, if you have custom HTML elements like this X button element here, and you want to say, okay, all X button elements are in fact buttons, then you can say use the tag to generic classes parameter of the install CustomWebResolver call, and then you write the X button equals button. So here, please be aware that we use uppercases here for tag names. So since HTML does not care, we care with uppercase. You can see directly this is a tag, this writing, and otherwise it's the same with generic classes parameter. On the left side, you have the thing you find in the web page, and then on the right side, you write the generic class which QFTest should use. If you have any question, by the way, just write it in the chat and I try to answer it as quickly as possible. I've already said sometimes you don't want to use directly the CSS classes, but any other HTML attribute, like for example the role attribute or anything else. So therefore it's interesting to have the attributes to generic classes parameter. And here exactly we have the case where we have an element, like again a div element with an attribute named role, and then the btn value. And we want to say, okay, we want a button. So in the end, it's again the generic class button. And in the front, we now say, okay, the attribute role should have the value btn. So this altogether makes the parameter role equals btn. So this is like the origin, and then this should map to, so equals, again, button. And this all in the attribute to generic classes parameter. And now QFTest, when the install CustomWebResolver call is executed, knows that every element with the role attribute set to btn should be treated as button. Sometimes you want to further precise these assignments. So, or lose them, like you want here, for example, not only the btn, but also a btn 1, 2, 3 or something like this. Or in my example here, I want to map any element which has a CSS class named list1, list2, list3, or list with any other character afterwards to a list. Therefore, we can use the person sign, and then add to the person sign, we can add a regular expression afterwards. So regular expression says that we use here for the Java regular expression engine. You can look up in the JDK documentation, Java documentation, in the pattern class. Everything else, everything there is explained which kind of patterns you can use here to match not only a dedicated string or a dedicated CSS class here, but also other classes which match the regular expression. And then there might be the case where you say, okay, I have a concrete mapping, but I just want to have this mapping active when, for example, the CSS class is assigned to a specific DOM node with a specific type tag. So you can say, okay, let's limit this to some distinct tag. Like for example, here we just want to have DOM nodes with the list item CSS class mapped to the generic class list item in QFTest when the DOM node has the tag li. We write it like this. We just put the equals and then the li symbol in the end, or the li string. And this reads a CSS list item class should, or a DOM node with a CSS list item class should be mapped to the generic class list item if it is a tag LE. Sometimes we also want to reference not only the DOM node itself, but we want to see in which context the DOM node stays in the web page. And therefore we can limit rules also to the parents. For example, we can say the list item can be mapped to, or the element with list item should be mapped to the generic list item class only if the parent of the DOM node has the generic class list. So if there is some other rule which assigns to the parent the generic name list, this rule must be earlier in your lists of assignments. So QFTest knows at the execution time that this is already a list. You can also extend this parameter with some quad braces where you you could say, I want the second parent, for example, here to be a list item. So you write list item equals list item at double colon parent and then the 2 there to really select only this rule when the parent on the second level has the QFTest assigned generic class name list. And if you don't want to exactly specify the parent, but you say, well, it must be somewhere within something. So for example, here, a checkbox should only be selected from a CSS check class if this is in some myPanel DOM node contained. So here I said sometimes it makes sense to invent your own generic classes. In this case, I invented the generic class myPanel, and it's only used here for reference in other rules. QFTest itself doesn't know about myPanel and doesn't know about features of myPanel, so cannot execute any special checks there, but just the checks which are normally available for the corresponding DOM node. But we can use it here as selector for special elements or for references. And as well, you can limit here with the number and squared braces afterwards that only up to the 5th level the entries should be a myPanel element. So when I say the next level, it's a question, what is the next upper level? What is the parent for QFTest? And that's not so easy. So you might say, okay, I can just open my DevTools in the browser and inspect the element. And then I see, okay, what is the parent element? And this is the parent element for QFTest. But, well, I have to say it depends. It depends on what QFTest sees as interesting elements. I'm sorry that I didn't translate this. It is really dependent. The layers are dependent from the ignored or interested tags seen by a QFTest. If you reference directly the parent and have no special resolvers installed, it's exactly the same as if you see in the DevTools. The parent is the direct parent. But if you introduce, for example, the ignore by attributes parameter to your install CustomWebResolver call and tell QFTest by this, well, ignore all elements. Some attribute has some value. In this case, well, the ID attribute has the bar value. Then for QFTest, this level is not interesting anymore, so it's not counted here. So the direct parent is now the element before, so this one with the foo name here. Or you can use the ignore tags parameter for the install CustomWebResolver call to select a whole class of tags to be ignored. For example, ignore all divs. And then the direct parent of our link here is the body element, because all the layers in between are invisible for a QF test. And you can like combine different parameters for the install custom resolver here. For example, you can add now the interesting by attributes, which says, well, ignore all divs here because ignore by tags is set to div, but all elements with the attribute ID set to bar, still interesting. And then we're like in the beginning having the ID bar at the as a direct parent for our link. So when you use the parent or ancestor addition to your parameter definitions, be aware of the view of QF test on your web page and which levels are filtered, which levels are visible. But you can see that easily when you say I record a component or record a click on a component, and then you inspect the hierarchy which is created by QF test to recognize the component here. And then I said, well, there are complex components. Complex components for QF test are components which consist of other sub-items, sub-components, which are important to define the complete component here. Those complex components contain lists. These are ComboBoxes, tables, TabPanels, accordions, trees, and TreeTables. And we want to have a short look on them, each of them, to see what is important to define such an element and how you can use that for your web page and web application. The easiest one is list. A list contains of a container element. So you say, okay, everything inside this container element is the list. And then you have to tell QF test, and these elements here are the items. And then QF test can execute list checks like check the complete list, check single item, select single item by name or by ID, count items, etc. This is how you define lists. And then there are optional elements, like, for example, checkboxes or icons, which QF test can check as well when you tell it. But if you are not available, you don't have to assign them anyhow, so QF test cannot check anything then. Another complex component is the combo box. A combo box, in fact, is like an extended list, which is hidden by default and which can be shown with a drop-down. So for the combo box, again, you have to assign the container. So to tell QF test, this is a combo box and everything inside might be interesting. Then you define the combo box list for the combo box and the combo box list items inside the combo box list. And then you have, again, the optional attributes to say, okay, there is some text field where you can check text or enter text. Or here is the button to drop down the combo box. This is especially important if your framework is built in a way that the list itself is not visible when the combo box is not dropped down. And then again, you can say, okay, this is a checkbox in the list and this is an icon in the list to make image checks on the icons or to make selection events, replay selection events, check the checked field, the checkbox state here, and so on. By the way, if you have a standard select tag and a standard HTML select list, then it's recorded in kind of a little bit different way because it does not consist of a list element you can directly identify. Then QF test records a select node and a select event on the list, which can be replayed then nicely. Another complex component which is used pretty often is the table. And for QF test, the table consists again of the container, which is the table. It consists of rows, like the table rows, and then inside the rows of cells. So you teach QF test how to identify all this. We will see this in an example later. This is kind of like with the HTML from the 90s, where you have the table and then the TR and the TD tags inside. But often these tables have not been used or even are not used only for defining tables, but also for defining a page layout, and therefore QF test by default does not assign automatically a table class to any table tag, but you have to teach it. And then because QF test is able to select elements from tables by the means of the header name, you have to teach QF test what is the header of the table and what are the header cells. And then there again are checkboxes and icons, which maybe are available inside the components or inside the cells here. You can teach QFTest how to interact with them or how to identify them for interaction. And then there is a tab panel to structure the web element into several panes. And you teach QFTest what is the container again, and what are the items to select different tabs. And then you can also teach QFTest by assigning the correct generic class name, what is the panel for the tabs, where you can close it, what is the icon and the checkbox again. And like a word list is like a horizontal selection, and if you have this in a vertical way, it is called accordion. In fact, this is like a tab panel selection. So we have the same generic classes, only with the accordion string in the beginning instead of the tab panel string. So again, the container, and then the items, and optionally the content, the closer, the checkbox, and the icon. And then there are the trees from my example in the beginning, where we have a kind of hierarchical information structure, which consists of the container tree, of the tree nodes, so the elements to see, probably again with checkboxes and icons. And then, very important for a tree, there is the expander to show the content of a subtree, so of an element. So if an element is not a leaf, then QFTest has to know how to interact with the expander, where to find the expander, because often HTML frameworks do not render the content of a subtree here before the parent is expanded for optimization issues. So QFTest has really to expand every level where a check to be done or an event has to be replayed in order to get the information and to visualize the information. And you can combine trees with tables in a tree table. Again, you have the tree table itself, the nodes, and the expander recognition, and the checkboxes and icons you can assign again to teach QFTest how to interact with that. All of this helps you to customize the view of QFTest on your application in a way that QFTest understands the semantic of your web application and knows how to select the correct algorithms to interact with it. But sometimes you say, okay, in fact, we have a web application which is, for example, written with an Angular framework, and I just want to tweak one parameter or two, and otherwise the default QFTest Angular custom web resolver is fine. I don't want to like redefine all the associations, all the assignments, just modify one a little bit. So this is all great. You don't have to start with the custom web resolver, but you can use an existing web resolver, for example here, an Angular web resolver, and then just add specific parameters which are missing for your dedicated application. Here, for example, some generic class assignments are given, some attribute to generic classes are defined, and so on. You can like expand on what we have, what QFTest already brings with it, and then extend this information with your dedicated customization. And that like get the power from both worlds, the power from the QFTest developers, which are already predefined most of the relevant resolver rules here for your application, and then you just extend by those rules which were missing. Take a look on time. It's really fine. We have time enough for a demo, so let's do a demo. So here is QFTest, and with QFTest there are a lot of sample test suites. Let's use the webcar config test suite for demonstration purposes here. This comes with QFTest out of the box and shows some examples, and when I just start the dependency here, it will start up a Chrome browser, in my case, with this like demo application, which is used not by any car seller I know, but well, which mimics the program used by a car seller. And when I do like record here, for example, the interaction with the table in the middle, just open a new test suite to have everything clean here, and I just clear my terminal so you can see everything what happens. And I now record a click on the model headline, and then I like select Razan family car here, and I say stop. So let's inspect what happened. Well, QFTest recorded my 2 clicks, that's fine. But as I said, it records the clicks not on a table, so not on a element with the generic class name table. So it doesn't say here anything about I clicked on the table and then on the header model, or I clicked on the cell Rasant family within the model column, but it says I clicked on some TD, which is in a TR, which is in a T-body, which is in a table, and so on. So this is not so nice. So let's get started with CustomWebResolver to improve this recording. I said installing a CustomWebResolver is in fact the same as executing a procedure. So I say I want to insert here procedure call. And I can select the procedure from the QFS-QFT, the standard library, which is included in every test suite automatically. And it's called install CustomWebResolver. So, okay. And now it asks me for some parameters. And you probably remember the parameters here from the presentation. We just leave it for a second like this. And when I now execute it, it says installed CustomWebResolver here in the terminal. In fact, it installed now the CustomWebResolver with, no parameters, so no special rules. When I now record the click again, it will do the same thing like here. So when I now say, okay, now let's click on this one. Okay, stop. You see nothing changed. Installing it like this without any customization does not help. We now want to see how this table is built in the HTML code to define the rules for our CustomWebResolver. So I now say I want to inspect this here, inspect my element, for example here, this one, and I take a look here in my DevTools, and I see, okay, there are some CSS classes defined, which are called data row and data cell, data table, header row, and probably header cell. Oh, well, that's great. That's exactly the thing we need for our CustomWebResolver. I can also see this here in QF-Test. I don't have to open the DevTools at all because CSS classes are part of the extra features which QF-Test records automatically for all our elements. So when I here see my, let's say, bad recording, it contains here already the classes which I was looking for. So the data cell class, header cell class, and so on. So I can now say, okay, I want to map directly CSS classes to generic classes. So I can say generic classes here and say, okay, data table should be mapped to table. Data row should be mapped to a table row. Data cell should be mapped to a table cell. I have to look for the header. I don't have it in my heart. I don't know it by heart. So header row and header cell. Header row should be a table header row. And header cell should be a table header cell. Okay, let's have a look again on the slides just to make sure that we didn't forget anything. So table, table row, table cell, table header, and table header cell. So there was a typo here. Table header without row. And when I now install this, you see two things. One, it says uninstall CustomWebResolver here. That means, there can also be one CustomWebResolver active at any time. So the old CustomWebResolver is removed. We can also do this with the procedure call uninstall CustomWebResolver. That would do the same thing, like uninstall it. And then it says again, install CustomWebResolver, and we don't see anything else of it. But as soon as we now re-record our little sequence here, so I click on model and then I click on Rasant family. and I inspect the recording. It now has exactly what we expect. So I configured my QFTest here to only use the names. It probably could have also used here IDs. So here my mapping has led QFTest to identify the elements by the names. I'm just a little bit confused because it has written rather than family here instead of model. It knows it's a table, that's fine. And also fine, the click is fine here. So it clicks on the correct item. Probably there was some intermediate step missing during my installation and uninstallation. The interesting thing about uninstallation is when I now say I uninstall the custom web resolver and then I execute my recording, which was made with the custom web resolver, it doesn't do anything, and there will be a component not found exception in a minute because, well, now the view on which QFTest has on the application changed. Defining the custom web resolver should be something which you do early within the part of your test development, or you have to decide to distinct in your test execution which parts have been recorded with the custom web resolver and which parts have been recorded without, because QFTest will use other means to record and then also to record and to replay your events and your checks, because, well, there's a different view on it. When I now install the custom web resolver again and then execute the click here, I can also say, for example, on another element, then everything is fine again, worked out fine. The correct element was selected. Always be aware of having the proper custom web resolver available when replaying, or the same custom web resolver available, at least a compatible one, when replaying as for recording time or for component definition time. Defining tree tables, defining trees, lists, etc. are always the same. So you inspect the classes, you inspect the HTML code for identifications of the element to see how can I safely identify the element, and then you use the parameters of the install custom web resolver call to teach QFTest these findings, to teach the mappings from elements available in the HTML code to generic classes. You can say, okay, probably you don't want to have this long list here. The table should be directly within the body. You don't want the div and the center here. I change here, for example, I add ignore tags and I say, okay, div and center are not interesting. And when I now do this and then click somewhere, the table element here is directly located under the body because the center and the div are not interesting anymore for QFTest. So that's about the custom web resolver. We have still some minutes left if there are questions. Otherwise, feel free to write an email to support@qfs.de when you have any troubles with the custom web resolver, and we're happy to help you out with it. The question was, in this example, would accessing table row number 6 cause a bounds exception? Well, let's try. Accessing number 6 means saying and 5, because computer scientists always start counting with 0. And let's execute the click. And it clicked on the last one. And I now say 6. It does not click. And it says no item was found for index 6. So 5 selects the last one. for this one. So it counts the header line with it. You can also use it now, for example, to find out how many elements are there in the list, either by iterating through it, or there are a lot of procedures in the standard library. For example, here for web, and in the web part, there's table, and then there's, for example, get column count here. And I say, okay, my element is vehicle table 2. And I call the procedure. And now I got some return value, and it says we have 2 columns, which is correct, which is the model, and then the price. Only possible because QFTest now knows that this is a table. And you all have this demo suite with QFTest, and the fourth part of the demo suite is also usage of CustomWebResolver, and there you find more examples of how to use the CustomWebResolver. Then I thank you very much for participating in this webinar. I hope you can use the information with your SUT to stabilize your tests, and you are happy to use QFTest to test your applications and to increase the quality of your product. Thank you very much.